This last question shows a slightly modified graph. Remember, the first graph had a peak and then came down into this section. So this graph here shows the flat top, and it says this is what the variation in the gravitational field strength is like as you move out, with once again the surface being roughly around where that R value is, which is the radius of the Earth. So it's asking, what does the graph tell us about the interior structure of the Earth? Well, the main thing we can see is you actually hit the peak gravitational field strength somewhere below the surface of the Earth, and that indicates to us that if we draw the Earth over here, and we've got an inner section and we've got an outer section here, where the outer section is of a density, that is, the amount of mass in that section is much less compared to the inside section. So the most mass of the Earth, capital M if you like, is concentrated in the centre, which explains why you've got this uniform increase during as you move from this section through here. Just to make that clear again, remember that is R, that distance there from the centre is the full radius, and if we called this point A, this would be roughly point A where that central region begins. So just to recap really clearly, the main focus of this question is to find out why we've got this flat section on the graph, and that's because the outer layers are of much lower density compared to the inner layer, or the inner section, resulting in a lower gravitational field strength increase, if at all. It appears that it's basically zero increase, so the density must be very low in that outer layer compared to the inner layer. The scale on this graph is unclear. We don't know whether this is 100 meters or whether it's 2 kilometers, but I suspect it's quite a small region, just the crust of the Earth. That would be my guess.